Hello, my name is Scott Pettygrove, and I'm a product line manager for Viavi's Antenna Test Group. Thank you for joining us today to discuss aligning antennas for point-to-point communications links using the RF Vision. If you're watching this video, you likely already have some degree of familiarity with the RF Vision's focus. Our mission is to ensure accurate alignment of site antennas per the RF design intent during both installation and maintenance. We do this by combining a high-precision GNSS receiver, a built-in camera that is mechanically aligned to the bore side of the attached antenna, a rugged 5-inch touchscreen, and an intuitive augmented reality-based targeting system into a complete, lightweight, and easy-to-use antenna alignment solution. That complete solution has these notable attributes. Firstly, we want to get you aligned more quickly. We do that in a couple of ways, primarily with our new GNSS receiver, which has multiple constellation support and dual frequency support. In the recent past, we've supported both GPS and GLONASS systems, but as of February of 2023, we've added Galileo, Baidu, and QZSS constellations as well. Each of these constellations supports two frequencies, one in the 1500 megahertz range and one in the 1200 megahertz range. So 5 constellations now instead of 2. The more constellations and frequencies that the GNSS receiver can see, the faster you can get aligned. We also help you to see and report exactly what your antenna sees. So we have a unique mechanically aligned line of sight survey that is driven by our mechanically aligned camera that's built into the unit. This helps you to understand if the coverage that your antenna sees is jeopardized by obstructions, both far field and near field, including potential PIM generators. It's rugged, very compact, and lightweight. It's the perfect companion for those long days in the field. It's one tool for all your alignment needs, whether it's for panel antennas, microwave antennas, cylindrical, and/or small cell antennas. And our solution also acts to reduce the amount of time from the assignment of work to the validation of the work performed. We do that in a couple of ways. One, with automatic reporting and results uploads to StrataSync, which is Viavi's cloud-based asset and data management system. And optionally, with StrataSync's end-to-end job-oriented workflow. And with StrataSync workflow, you enter the job specifics into a form in the cloud. You push the job to a specific technician and instrument. You pick the job from a list that's then represented on the RF Vision screen itself. You align to the configuration that's been passed to that job, and then automatically save the results and reports back to StrataSync. Though it's not the primary focus of our discussion today, if you find that StrataSync workflow intrigues you, please reach out to your local Viavi sales rep to find out more. The whole goal is to ensure that what you install and deploy matches the intent of the planned RF design, unless, of course, our line of sight camera shows you that the planned design might not be achieving the expected coverage or brings potential near-field PIM sources into view. We spend much of our time talking to folks about the importance of accurate alignment of panel antennas for cellular applications, and there are good reasons for that. Incorrectly aligned panel antennas can result in RF coverage gaps, overlaps, and interference, reduced capacity for the antenna for the site as a whole, increased handover failures, and with that comes increased drop calls, possibly subscriber frustration and churn, as well as increased potential for repeat site visits if you're not aware that the problem that you're trying to solve is actually related to misaligned antennas. But we don't normally spend as much time talking about the criticality of point-to-point antenna alignment, though you can argue that the effects of misalignment here could be even more severe, where one misaligned antenna in a microwave backhaul link, for instance, could bring down the entire site. So accurate alignment of microwave links is fundamental to service quality and customer satisfaction on that link. Poorly aligned links can result in degraded link capacity and reliability, increased wind and vibration sensitivity, loss of link redundancy and therefore potential impact to SLAs in place, service outage and revenue interruptions, as well as customer churn and revenue loss. So when it comes to using the RF Vision to align microwave links, there are two primary use cases that apply. First is to use two RF Visions and two climbers to simultaneously align both ends of the link. This is the fastest and the most efficient approach. The second is to use one RF vision and one climber to iteratively align both ends of the link. And this method is effective, but takes longer and quite a bit more energy. So using the RF vision, microwave dish alignment is optimized at each end of the link by aligning the near side antenna onto the main lobe of the far side antenna. And we can do this without installing and/or powering the antenna radios. This makes fine-tuning of the antennas to top dead center of the main lobe with a digital voltmeter much faster and easier after the radios are installed and powered up. Now let's discuss how the RF vision accomplishes microwave antenna alignment in a little more detail. When aligning point-to-point links, the RF vision will use 2 points in space to calculate azimuth and tilt alignment targets. Each point is described by the respective antenna's latitude, longitude, and AMSL height, where AMSL stands for above mean sea level. And using AMSL height allows for absolute height references for each antenna. Height above ground is relative and is normally different for each site and therefore not used. The RF vision mounted on side A will use point A, measured by the RF vision GNSS receiver, and point B, entered into the RF vision UI by the user, to calculate the alignment targets for path A to B in the form of target azimuth and tilt. Likewise, the RF vision mounted on side B will use measured point B and user entered point A to calculate the alignment targets for path B to A. To show how this is accomplished on the RF vision, let's walk through the microwave alignment application. To align microwave antennas, select the Microwave Align icon on the RF vision's main screen. Here's a view of the microwave alignment screen. The box in the lower right-hand corner contains information about your local latitude, longitude, and AMSL height measured by the RF vision GNSS receiver. Make sure that your height input is set to GPS AMSL height in the settings menu. Touch the box in the lower left-hand corner to enter the latitude, longitude, and AMSL height for the far end antenna. That will take you to the path information screen, where you enter the path ID and the latitude, longitude, and AMSL height of the far end antenna. This information could be derived from the link design parameters, provided to you by a coworker at the far end, or captured by you on a prior visit to the far end. Note that the latitude and longitude are always entered in decimal degree format in this screen. Select Accept when you're done. This will bring you back to the microwave alignment screen, where your new azimuth and tilt target values will be shown. Align the antenna to the target values using the RF Vision's augmented reality alignment system, and when the bullseye turns from red to green, lock your antenna down. While aligning, please make sure to give the bullseye target at least 5 seconds of settling time to allow for our smoothing algorithms to complete their work. Select Save, and you're done. With that under our belt, let's talk in more detail about the 2 primary use cases for microwave alignment with the RF Vision. The first use case is alignment with 2 RF Visions. Using an RF Vision on each side of the link simultaneously will expedite the alignment process substantially. Begin by mounting one RF Vision on the side A antenna and another on the side B antenna, and wait until the RF Visions obtain GNSS lock. At this point, the operators on each side will communicate with each other via voice, text, or email. The operator on side A will input the location values measured by the RF Vision attached on side B, and the operator on side B will enter the location values measured on side A. Both operators then proceed to align their azimuth and tilt targets using the augmented reality alignment system. The second use case is alignment with one operator and one RF vision. Mount the RF vision on the side A antenna and enter the latitude, longitude, and AMSL height of the far end antenna based on link design parameters. Align the antenna on side A to the bullseye target and save the report. This is very important to do this. You'll need the information from that report when you get to side B. Now take the RF vision to the side B antenna, mount it, and enter latitude, longitude, and height values saved during the side A alignment. Align the antenna on side B to the bullseye target and save the report. If the side B actual values differ significantly from the original design targets, you may need to revisit side A and repeat the alignment using the saved values that you obtained during the side B visit. So before we wrap up, let's talk briefly about what comes with the standard RF Vision 2000 kit. The kit includes the RF Vision antenna alignment tool, a universal strap clamp for use on a variety of antenna types, a soft padded carry bag, a hard carry case for protected transport to and from the site, an AC to DC power supply with universal wall adapter system, and a USB cable for power and data connectivity. Viavi carries a variety of optional accessories for the RF Vision. Some that are particularly valuable for microwave applications are the lip clamp, which attaches to the top lip of some dish-style antennas where there is not room for the standard clamp. The extended lip clamp, a variation of the lip clamp that accommodates larger clamp depth. The extended lip clamp with L backplate that registers to the top of the antenna's lip to make the attachment quick and secure. And a set of extended straps for the universal strap clamp to allow use on dishes up to 12 feet in diameter. So in summary, here's what we've covered today. The RF Vision quickly and easily aligns antennas in a point-to-point link prior to installing and powering the antenna radios. The fastest method to align both antennas on a link is to use two RF Visions simultaneously, though a single unit can be used if you have the time. The RF Vision quickly points microwave antennas onto the main lobe of the opposite antenna in a link. Subsequent fine-tuning of the alignment to top dead center of the main lobe normally requires powering the antenna radios and the use of a digital voltmeter to optimize received signal strength. So that's all we have today. Thank you very much for spending time with us. And we hope that you found that this information was both helpful and useful. If you'd like to know more about Viavi's RF Vision antenna alignment tool or other Viavi tools to help you with your RF, fiber, and coax testing needs, please reach out to your nearest Viavi sales representative or authorized dealer, or contact us at www.viavisolutions.com. And to all you bold and brave tower climbers, have a great day up there in the clouds.